Okay, so we're really happy to have our speaker today, Polly Hudson, who's a senior research fellow at the Turing Institute, and she's been working on something called the Coloring Cities Research Program, and she's worked with a number of other places, including UCL, I guess, and Kellogg Center, Oxford, and British RIBA, the Royal Institute of British Architects, and the National Lottery. You have the National Lottery on the board. Okay. Oh, sorry, advisory board position, right? But she's an architectural historian, and she set up the Building Exploratory Charitable Trust in London, and has set up a citizen science program called Coloring Cities. Who's going to tell us about. So, thank you very much for coming and look forward to your talk.
So I'm not going to talk about anything technical today. I'm going to kind of talk to you about sharing stuff, kind of, and things in academia, and kind of what we're trying to kind of look at. So, what is the program, the Coloring Cities Research Program? So we're an informal global academic consortium. That's the first thing. We're informal. We have no formal agreements between countries or between research groups, because they just slow everything down. We're co-creating a decentralized network of open, interoperable, permanent spatial data platforms. And we're also building a kind of network of research groups linked to these. And the point is to accelerate UN SDGs and to lift some of the blockers that we think exist. So we focus on the building stock, but we're expanding that into blue-green infrastructure because we're realizing that that's obviously kind of very important to do, and it's kind of good to co-work on that.
Sorry, what is blue-green?
Oh, sort of water and natural landscape.
Okay, thank you.
And we look at, in terms of the stocks, building stock, we look at the characteristics of the stock, so sort of basic attributes like age or typology, performance, so that can be energy performance, or it could be user reaction to the building, you know, kind of somebody walking down the street, whether it actually contributes to the streetscape, and critically dynamics. So we look at short-term dynamics as in planning data and long-term dynamics as in historical mapping data, time series data. All our code, data and methods are released under open licenses. We currently work across 30 countries, and we have 6 global hubs and expert data groups that are linked to these. And all of these are voluntary. Okay, so everything we do is about researchers just thinking, like you were talking about having your informal group, you know, it's like that. That's how we work. So the critical thing is about pooling of research expertise and funded research time. Because, you know, you've got, and kind of stopping reinventing the wheel. And you've obviously already brought that up in this meeting. You know, it's when you work across countries like this, you realize that just so many people are doing the same thing. And there are huge amounts of their own brain power. They're using funding time, they're using resources that could actually be pooled, and that foundational work could be done much faster, and it could allow them to then work much more, you know, much more effectively on the research question they want. And just to say that I went to it was OECD UN World Bank meeting in Paris 2 weeks ago, and there were a number of us that spoke from academia, government, private sector, or whatever, on building attribute data, kind of. And the biggest thing that came out of it was that there were just overlaps absolutely everywhere. And this is very large-scale research funding, or funding that's kind of being wasted, in my view. And it's also we are also non-competitive. As you might know, in academia can be quite competitive. And so actually, we think, well, and I came into academia late, and I just didn't understand it. I just didn't understand why people couldn't collaborate and cooperate and share things, and why we all had to kind of go like this. And it was worse, I found, within the actual universities, because the departments didn't want to, other departments didn't want to collaborate with me at UCL, because they were kind of going, well, we're going for that grant. And I'm like, well, why don't we just go for it together? You know, or because if we overlap anyway, oh, no, we need to do that. So it's a kind of, we've been going 10 years, and I feel we've kind of just started. So you can see on the images the hubs and the kind of spread. So so far. So really don't worry about the text on this, but if you look at the images on the right-hand side, it's just this thing of kind of, you know, if you want to make vitamin products or juice or marmalade, you all want the oranges. We all want the oranges, so why don't you just work on the oranges together? And then various bits of the processing, so you can just get on with it. So it's moving from a kind of model of individual research being the big thing that we do in academia to it actually being the small thing. So that's what I think is kind of interesting. So why do we need the Coloring Cities programme? Because we need comprehensible, reliable data on the built and natural environment. I mean, it's mainly built so far, so I'll kind of focus more on that. And we need it for kind of housing, planning, conservation, energy, disaster management, economics, you name it. I mean, we spend a huge amount of time in buildings, and so obviously they have effects on numerous aspects of socioeconomic and environmental impact. And this thing of accelerating UN SDGs and net zero. Also, we need the big data to exploit the AI and machine learning capabilities. And that, if it's highly fragmented as it is, that's actually very difficult to do. So it's the kind of thing like, how do you bring it together in a way where it's standardised across countries, so it's much faster for researchers, not just to work within countries, but across countries too. And so we are very interested in this kind of sustainable or unsustainable long-term patterns as well. So this thing about kind of tracking cycles and understanding how that works over like 100-year periods. That's a kind of big aspect of our work, and I'll just show you a few things on that later. And so we use multiple methods of data collection. So we use crowdsourcing, live streaming of official data, inference using computational approaches, and feedbacks between those. And so you can start cross-checking the data, which is the next stage of our work. And really it goes down to this thing of kind of cells. You know, we work with building polygons, the building footprints, or land parcel data. And we argue that, in medicine, you wouldn't even think of not looking at cell level. You wouldn't even dream of it when you're kind of, trying to understand how to solve the problem. Whereas in the built environment, the natural environment, for a long time, we kind of might look at network data or heavily aggregated data, but we don't look at it at cell level. And so our hypothesis is that when you start getting this data that's standardized at the microspatial level, it will accelerate, the research will accelerate. The problem solving will accelerate because you're joining your network data with your cell data, as happens in sort of biological research, whatever. So yes, academia, highly inefficient in my view, highly competitive, needs a bit of a look at, I would say. So why do we work, how do we work, and why do we work in this way? So we're academia-led. This means that we're research-focused, and it also helps build trust. We all have a kind of ethical framework that's similar to work in, makes it very simple. We're decentralized because we want the platforms to be run at national level and therefore to be local networks. It makes it much more rich, it makes it much more resilient. It means any component can collapse and the whole infrastructure will still exist. So you'd have to have multiple components to collapse for it to stop. We co-work internationally on the technical side. So we have an international technical group run by Canada, and so that's cheaper, faster, more exciting, more efficient. It's on plugins, on interface. It could be on the back end. It could be anything. There's no point in kind of each country. So you could be working on platforms in each country. Well, why not just work on one system and all work on have a load of people work on the back end, a load of people working on the front end across countries, so that it's kind of, and they make that have translation tools and etc. etc. So it's this thing about, can you pool your budget? So are you prepared to kind of pool your budget and tell people about your ideas? That's the first blocker. And are you interested in open data and open research? So if you are, then we're kind of the people that you like. And that means that people in our group are that kind of, if you want to work with those kind of people, then you can come and meet them through our group. So what we don't want is people who want to come and take money out of the group because they think, you know, they can win a funding grant. It's about putting it in and getting a lot more back and understanding how that works and why it works in that way, kind of thing. But of course, academics, in order to justify that, have to produce stuff. So we always work on papers together. It's the first thing we start on. You know, we have expert groups, they're working on a paper. We have a collaboration, they're working on a paper, because it ticks that box, and then we do joint funding bids kind of as well. And so we have these expert groups who advise on the data classes across countries. They also enable testing data in multiple applications. So we focus also on working with colleagues who are specialists in AI and machine learning as well. And as I said, so we have the same, you can see it's the same interface. So our code are open, they're on GitHub, you can use them, do whatever you want with them, but you can't join our program unless you're an academic researcher. So it doesn't mean to say that you can't use the code, it just means that otherwise people can call themselves a Colouring Cities platform and actually have no interest in ethics, have no interest in security and privacy, have no interest in, do you know what I mean? So we're value-led, and I really love these matrix values. And so I'm putting them up here because we have kind of quite long protocols that are in our open manual. But I love these ones because this is exactly what we do. It's about kind of not the individual, the bigger system, openness, interoperability, cross-platform, accessibility, transparency, empathy, pragmatism, proof. They're all exactly what we look to do as well. And so this non-competitive, ego-free research is at the core of what we're doing. So this is what the interface looks like. It's looked very much like that for 10 years. It could change over time, but it's basically got these 12 main data categories. And within those, there are subcategories, many 150 or so subcategories. So the idea is you get messy data, you push it through our system, and you get it clean, standardized, and you know where the gaps are, and you can use that cross countries very easily to collaborate on research. So we look at this collation, classification, standardization, updating is very important. How do we get updated data? Visualization, very important. We use nudge effects, which I'll talk about in a sec. And this uncertainty quantification, which we're hoping to work with Oak Ridge National Laboratory. And the biggest issue perhaps we work on is privacy and security in terms of identifying across countries what the privacy concerns are. Because when you're working with geospatial data and you're dealing with people's homes or private land, you can connect, and you start having text boxes that you can connect to it. People can just write any old stuff about you in there, mean stuff. So you have to be super careful. And at the moment, people are just, you know, releasing open footprints, which of course, you know, we want open data, but that's actually going to be very problematic if you've got malicious people using these and trying to connect. You know, so that's what we keep all our footprints behind a firewall. So they are the cells, and we keep behind a firewall just to promote this.
Can I just ask a couple of questions about
Yes,
this?
sorry.
What is the resolution of your typical data set here?
So it's building level.
Building. So but it's accurate down to 10 centimeters, 5 centimeters. What's the precision there?
So we don't really kind of see it like that. We'll have, say, the attributes of a building will be the age of that structure.
No, but I mean, let's say the corner of the building is here. It could be a meter off, it could be 10 meters off. So in terms of the precise.
Okay, so that depends on that will depend on the footprints that you're using. So I'll talk about the footprints in a sec, because that's a problematic area, and and it affects some of the data and other types of data set not.
Right. Okay.
So I won't go into this. This is basically how they're set up, but and you can have the slides, so you can just read them whenever you want. But the main thing is that they're kind of just set up by an academic approaching us and going like, we're interested in setting up a national platform, and we kind of go, oh great, can you just read our protocols? You know, prove that you're a research organisation, have a meeting with us, and then they take our code from GitHub and they just join it to open footprints, and they can just set up a platform straight away. And as soon as they do that, sorry, they can access all these things. So they access our global hubs and our regular meetings from there, our international technical group, our international expert groups, and our with the ops group kind of overseeing it. So it's designed to be decentralized. So a number of countries like hold the highest admin rights to GitHub and things like that. But that's quite difficult, getting that right. It takes a bit of a while. So once they set up the platform, what we say to them is, so in Australia, what they did was they had these data platforms for colouring Brisbane, colouring Perth, colouring whatever, and they were so inefficient. It was really important to see it. It was really, really inefficient because everybody would have to have, you know, a technical person to oversee the platform. Each university would have to allocate that. Each one would have to have their own PI. Each one would have to have their own funding. So we learned from that in the UK, and we just said we're not going to do it like this. We're going to have 1 or 2 universities who manage the platform. We're going to have oversight from 3 or 4 universities. So we have UCL, Oxford, Cambridge overseeing, which John is part of as well. And then we look at a national network of universities that help moderate the data. So what you can see on the right is our Dedan Kimathi University in Kenya. So this is mapping all the research organizations in Kenya. And the idea is that you have kind of regional hubs, and then they help collect data, but they do it because they need it for their own research. So everything is done because it's useful in research, not because you're doing it for favour. You're doing it because it's useful, but you actually then just release it to kind of everybody else.
And who's the Cambridge person? John, who's the Cambridge person?
Yeah.
Oh, okay. It's been keeping it very quiet.
Well, we only did it very recently because we're just moving from Turing, the British, so the Colouring Britain is moving to Loughborough University because they've been given £500,000 by the government just to work on Loughborough. And they've brought in a kind of whole load of other money as well. But we want this oversight group because universities tend to like to.
But in terms of researchers, who are the people? Is anybody at Cambridge using this data or contributing to it?
Well, we're hoping kind of maybe through these discussions.
No, we'd love to do this.
Well, Andreas in the group, Zunique Gonzalez. So I'll show a slide where he's linking in, and we're trying to kind of build that and make it connect more. Yeah, so this is an example of the energy expert group I just wanted to show. So this is chaired by Sweden. We have Sweden, Spain, UK, Canada, Germany, US, and the European Commission come and sit on it. They're really kind of informal, friendly groups. And then this is the beginning of understanding, re-looking at our data classes and understanding what data we need to collect across countries. And that could be network data, or it could be building level data as well, because we also want to do look at system integration as well, but that's more standard in GIS. So you can see how these begin to be sort of fleshed out, and then they start creating the subcategories and drop downs. And this is the beginning of the green infrastructure group. So this is what Andreas sits on this at the moment with us, and that's an image at the top of his work. And so in the last meeting, we're working with Germany as well. So we've got just a small group of people at the moment, but they're all looking at kind of automated extraction of data on trees. But Andreas is looking at so he's looking at current data and in relation to deprivation, which we think is super interesting. But our colleague Elle Smith, who's a PhD at Leeds, is looking at extraction from trees from historical maps. And our colleagues in Germany are looking at extraction of both types of data to look at change in forest over time. So they're all using it for kind of quite different reasons. But the idea is to kind of say, so we're also looking at, we have these booth poverty maps from 1890. So if you want to compare deprivation and trees now, we can also start extracting that, which EPFL Lausanne is doing in Switzerland. So they're working on extraction of historical data. So this is just trying to show you how this is a little group, okay? It's just about trees, But suddenly, very quickly, you start kind of getting all these really exciting ideas kind of going around, and then somebody goes, oh yeah, I know somebody's doing that, or I know somebody in another country is doing that, and then we send it through our groups, and then they go, oh yes, I'm working on trees, I'll come on that. So it's all happens very quickly and informally. And then we're looking at this impact study section kind of as well. So the data is really split into the actual, so location data, the attribute data, like whether it's what kind of land use or typology, age and history. Then we have a planning and conservation section, and then we have 2 sections for energy, which might be renamed. And then we have an urban infrastructure context and a blue-green infrastructure context. And that's really about the network. So that's kind of looking at transportation, it's looking at pavement width, it's looking at, or you know, like utilities, all this kind of thing. And then we have a disaster management section again, and community, and I'll just show you a few examples of these. So we have 150 plus nested categories. And what we're looking at is that if you want to create a new category, you can write the code for it, but it has to be open to the rest of the group. So you might write the code, so you have the standardized ones are agreed across the expert groups. And then all the countries are collecting those. But if you want to collect other ones, as long as you write code that's open in your repository that other people can take, then we really encourage it, and as long as it meets the protocols and security kind of stuff that we look at. And the idea is that if enough countries are picking a new type of data class or a code for that, and they're using it, then it will move up and it will go into our standardized ones, because we'll realize that all these countries need it. So maybe it should be one that we should be looking at across countries too. Reliability of the obvious question, kind of reliability. So we're just slowly kind of working on this. I mean, we have things like, we have a drop down for where you get it from. You know, is it inferred? Is it crowdsourced? Is it from an official data source? And then if it is, then what's the link to that? We have a standard OpenStreetMap edit history. We use this multi-method approach and try and cross-reference. But the next stage, as I said, is kind of this big move towards how we actually do that cross-checking in a more kind of automated way. So just to explain about footprints, these cells. In the UK is by far the worst of any country we work with for microspatial building attribute data. I mean, if you want open data, don't want open data, come to Britain or Australia, which are actually the top in the open data tables for everything else. Quite interesting that. The government refused to allow open footprints to be released. They have done. I worked in this area for 25 years, and so I've given up waiting. And we were allowed to use the master map footprints, the most detailed for London. Special, first time OS had ever done that. You know, ridiculous, so complicated. And so now we've just developed our own data set. So we built this data set with Loughborough. We basically take the Inspire land parcel ownership polygons, which are across Europe, which amazingly we still have. And we use them to split the Ordnance Survey block level data, and then we do kind of a whole load of cleaning processes. So if anybody wants that data, you are completely welcome to it. We are releasing it to anybody within academia, and then it'll go behind a firewall in our platform. But otherwise, we cannot collect anything. We can't collate and visualize anything because we don't have that basic building block. So it's taken a long time to work on that.
And this is for all of the UK, just like...
Actually, we can only do it for England and Wales for the UK because Scotland can't get access to the Inspire polygons for Scotland. So please feel free. And what I'm showing you here is, sorry, it's not this, I should be showing you a direct comparison, but on the right hand side, you look at the right bottom, you're looking at the master map paid for version. On the left, you're looking at Cambridge of our version, okay, which is live online now, so you can have a look at it if you want.
Here's the question.
I'm sorry, just on those footprints, aside from the physical footprints, are there any attributes about those buildings?
Oh yeah, so I'll show
Sort of thing.
what that are open.
Yes, or
Yes, so that is the problem at the moment, is
right.
that we're now looking to populate these different areas of building age, land use activity, whatever, And we're having to start from scratch on virtually everything in the UK, because at building level, it just, I mean, the government, the valuation office agency has data on every single building for tax purposes. It has age, I've done freedom of information applications and they won't even let me have the age. And I'm like, it's not private, the age, okay? No, you can't have it, we need a change in the law to release it. So what we're building is a parallel system to the valuation of these agencies. But ours is actually much more interesting because it can be updated and enriched from multiple sources, which is, you know, exciting. I actually haven't got the, oh yeah, so this is to show you kind of nudge behavior. So what we did was we wanted to test our live streaming of data using public APIs. So this is planning data, live streamed for the first time into building footprints that shows you the status of the planning application. So it shows you what's going on in the planning application, but it tells you whether it's been approved or whatever, because that's what communities really need to see. They need to understand that to know whether they should be commenting at local level on this. What you can see is that the colours on the right, on the green map, are mainly approved. So approved is the standard status. Oh, thank you. But you can see on the, sorry, on this one, see it's pink. So that immediately tells you that that's formatted wrong. Straight away you can see that. Harringay, what they do, they haven't done anything, right? And when we started doing this, there were loads of gaps with local authorities that have, this is a Greater London Authority API that we have, that they load up to, and then we're streaming from. But what's happened is that they started to fill in. We haven't done, we need to do like go talk to them all about it. But it's quite interesting, this sort of, the extent to which the mapping makes a difference in nudging people to get on with it, because you can now, you should be embarrassed if you own Harringay. You know, you really, really should be. And you know, the GLA can instantly see who's got the data up, where the issues might be occurring, etc. So it's kind of, so we use visualization in that way. We use that in our global maps too, to sort of nudge at global region level, and we have kind of leaderboards we're developing again. That's kind of quite a lot for the private sector. So I just wanted to show you land use because I thought you might be interested in this. And I'm sorry, this video is a little bit fast, I think, when it goes on. So what I'm showing you is trying to collect data on land use. It's really, really messy. In the UK, it's absolutely chaotic the way that, sorry, I'll just stop that for a sec. So in the UK, you have the best quality land use activity data. So is it, you know, is it a museum? Is it a shoe shop? Is it a whatever? Is it a shop? Is it a whatever? It comes from the valuation office agency again. So from the tax office, and they keep it up to date because it's about money. Anything where it's about money, it'll probably be, you know, the data's like they keep an eye on it. But it's actually different in across local authorities. It's collected differently, and it's not. It's so complicated, and they don't have a spatial. You don't link it to a spatial coordinate, so or a UPRN, so you can't. You don't know where it is. So we actually found that in Loughborough there was an example where we could map it using the VOA data, but for other, at the moment, for other local authorities, we can't. Now, this is very different in other countries. You go to Bogota, beautiful data. You know, you go to, I don't know, New York or where, you know, America, very good, a lot of property tax data released, or whatever. So, but here, really what I'm showing you is the fact that it's no good just putting in your national thing. What you really want to do is connect it to the other classification systems, because your national classification system for land use is going to be different to the one that's next door. They're all different. But if you actually connect it to the SIC codes and the sort of standard industrial classification codes internationally, or European level or whatever, it means, so what we've got in here is basically, sorry, there. Now what you're seeing now, let me just stop it there. So what it does is you enter into it in a drop down what the land use from the what's called the SCAP code, and it will automatically create a code that links to all the other kind of global systems wherever they exist. So it means that you can download it and you can just use the NACE system or the ISIC
So
system.
when you say you, this means be like, who would be the person doing this?
Who would be the person who is actually doing the
coding?
So we work with Loughborough University and a software engineer I've worked with a long time called Mateusz Paniecki, who works from Poland. So we've been working on this specific thing, but then we put the code in there as core code into the system, and then
So it's not the person actually clicking and doing all this work, right?
no. The idea is that if we have it as bulk data, then we can just put in all the scat codes.
Okay.
If the government gave us the scat codes, we just put it in, it would automatically give you the source, and it would automatically connect all of those to the international. So that's what, it's also about nudging kind of
Right.
government
Oh, I
to do
see.
that in that way. Sorry, I didn't explain that very well. And then on this one we just mocked up the other day, and this was, you might work with this Corinne land use kind of data. So this was taking the inspired parcels and looking at I'll put on, yeah, so the Copernicus data, and just doing a spatial join between the inspire land parcels and the land cover data. So you can then get the code. So this one, but so if it's obviously one color, you're just going to get one code related to it. But so we're looking at the moment about where you have, where it crosses over to, because what you want to do is show that that land parcel's got those two codes in it as well. So it's just sort of fiddling around with those bits, but actually, and then what we do is we go and say, okay, great, our colleagues in Germany or our colleagues in Kenya, how does this work with you? Okay, can you use the system? Does it make sense to you? And then we just sort of keep on improving and adapting it. Data trust, privacy, security, absolutely critical. So we were talking earlier about this, or in your group, you're talking about, well, Jessica as well, this thing of the trusted models and the kind of security. And so our colleagues in Germany have been working on this sort of trust model, and it's to do with energy data. And so we've been looking at whether we should have an iteration behind a firewall for more private data. But what they've been doing is they've been trying to get energy consumption data from residents, as many residents as possible as they can, so that they can do more detailed kind of analysis, because they can't get it from the energy companies because it's aggregated, and they want to relate it to the different building typologies. So what they're doing is they've got this trust model, and you will know of it, and I'm sorry that I haven't got it written down what it is, there's a name for it, where you might know, Jessica, so where you're putting it into a kind of secure area, like a super secure area, and then you can do the analysis in the area, but you can't actually, the data isn't actually shown on our system.
So like a sandbox?
Yeah, maybe. Yeah, I can't remember what the name is.
Enclave.
On.
Enclave is another word that people use.
Yes, I think it was that. So they're playing around with that, but obviously that's relevant across countries. So anybody who's interested in anything I'm bringing up, like we're interested in kind of working with you. I'm sorry, this is very faded. This is a really nice example of how the system is beginning to work. So what you're seeing on the first image is a sample, a crowdsourced sample looking at number of stories and buildings. And what they did was then they used this machine learning approach to infer it for the whole of Dresden. They checked that against the official data to see how accurate it was, and it actually wasn't doing too bad. And then they put it back, they put it into the system, they can put it into the colouring Dresden system, and then get it checked again by the crowd or verified. So the training data can keep improving as well. So it's kind of like starting to, but what was really nice about this was that this method was then written up as part of a Science Us bid by Greece and Turkey, and University of Istanbul and University of Patras, who run those platforms. And they won 40,000 like a couple of weeks ago. And they're looking at photovoltaic panels on roofs and typologies. And so they're going to start using this method. It's being tested in Germany, where they're combining the crowdsourcing and the machine learning. So it's just a really nice way of showing how things can kind of work. But it's also driving it means that the Istanbul, the Turkey platform can be set up because they'll have kickstart funding to kind of help with that process. Disaster, how am I doing for time?
Well, you have about 10 minutes.
Okay. So we also have active tools. So this shows you some work that they're doing in covering Indonesia, which just got £300,000 grant from the British Academy. It's to do with water encroaching and resettlement, particularly of the fishermen. You can just see some images at the top, but I also wanted to show you the bottom section. So this is a live data collection tool. So if you've got, say, a bombing in an area, so this was developed in 2020 with the Beirut blast damage. And what we wanted to do was to create a tool that was you could click on a building and you could immediately say what the level of severity of damage was to it. And that's what they had after the war. I don't know whether you've seen the bomb damage maps of London, but they're all colour-coded with 7 colours or whatever, according to how much damage there is. So you can immediately see where. So it means that if you've got, say, in Ukraine, you've got bombing in Ukraine, you can live collect data on that and use it for reconstruction. You can use it for kind of applying for grants to help. You can. But then you've got also how much information do you want to have publicly, on that thing as well. So you've got and we in Lebanon, for example, our colleagues at American University of Beirut didn't want to. They said we're not going to use the materials data at the micro level because of missile targeting. So there's so it's also kind of working out what you should be aggregating, sort of going back to the aggregation again, sometimes, going to the detail level and then saying for security, some things need to be aggregated. This I'm just going to show you because it's fun. This is something I did 20 years ago, but I actually wouldn't mind getting a bit closer to doing that again. So it's just animating buildings over a 250-year period. This is every building that was built in this area, moving up and down, because we are very interested in energy and waste flows over time and how you actually calculate that through collecting data on construction and demolition dates. So that's kind of that's a big over my sort of personal work. And just to finish, I just wanted to show you some work we're doing. Again, we're doing this with Loughborough, but also with a long-term colleague of mine, Flora Rumpani, who has been at UCL and Turing. So this one is, I don't know whether any of you work in procedural models. So this is moving into kind of the 3D domain. And so this is where we're working on typology. So Flora set up an open GitHub repo on, so looking at open procedural models. And so we're going to collect information on typology rules across countries so that we can start generating these simulations much more easily, where you can just look at the repercussions. Say, like below, we've got the flooding. Now you can see that when you simulate that flooding, actually you really need the basement data, because you really need to know how many people are likely to be stuck in there and the danger of it, as well as the cost of reconstruction or the millions of things. And so I will stop there. Sorry, I've really thrown a lot of information at you, and the slides are here, but it's really, I'm very grateful that you've invited me to talk, because we would love to work with anybody who might be interested. Jessica and I have been kind of chatting, and Andreas and I are chatting, and if it's of interest to you, just come and chat to me.
Thank you very much. Back to some questions. By the way, I should mention, maybe you should mention your work in procedural generation.
We previously worked on procedural generation of forest.
Ah,
So I just mentioned like the scaling of the data. We're actually doing the scaling of the synthetic data from a procedurally generated forest.
we'd have to.
So that allows us to collect a massive amount of data.
I think the point which is might be relevant here is because what Ihan does, and Ihan Frank did with creating these synthetic forests, you can train AI on the synthetic forests. So you can use the synthetic towns to actually train AI models, which then can be used in the real world.
Yeah, amazing. I'd love to know more about it.
Yeah, actually, I mean, you can use these building blocks to create like native view satellite imagery using to train like the segmentation of the building blocks. They're having some work to do that.
There's a word.
So this is what I mean, you know, in this room alone, there are a lot of people with a lot of very good and interesting ideas and have tested things already, but this is just one room. You know, it's just one room in this whole university. This is one university, and I mean, you just think if we could just join up a bit more, even a bit, we would be moving a lot faster.
Go ahead, Bernard.
Really amazing applications, and as you said, so many ways to look at the same sort of area and different things to try on. How did it come to kind of look at cities in the first place, on the grounds that there are so many other kind of international problems with the same domain stuff?
Yeah, so I suppose I've worked in buildings for years, and then I ran a charity for 7 years, which was co-built in Hackney in London, and it looked at kind of cross-sector communication about. It was like a model for how you could build physical interactive centres for local communities with local communities and across sectors. To actually understand what was going on largely in planning. So a lot was about the importance of buildings to people and the fact that they have very, very little say on them.
Mm.
And so that's kind of that's sort of how it started. And then I realised that, so I was working a lot with maps, and then I realised that the council had maps of all the buildings like in the whole area. And I was like, what? Okay, can we have this? And so they printed out all these maps, physical maps, and we had this giant thing. And I was going, so what's this digital stuff? And then I learned about GIS, and then I was like, oh my god, why don't we just build a GIS? Because they were doing stock transfers. So at that time, this is in the 90s. At that time, they were needing to. The government was trying to look at how you transferred from councils to housing associations. And so I was like, well, surely if you knew where all these were, like you knew where the council stock was, and you knew where the housing association, you knew where the housing association already had buildings, it would be more efficient to buy the ones that were kind of next door to each other. Mm. And they were like, do you have a map? And they were, no. And I was like, okay. So we managed to get 20,000, goodness knows how, from the housing ministry. And we built this GIS platform, which we weren't allowed to get online, obviously, because OS won't let you even now quick stuff online. And we had it on the intranet, and we had it in our charity. And it was just brilliant because we could start layering historical data, and we could we didn't do the crowdsourcing then, but we did the connection between past, present, and future. That's what we were interested in, understanding kind of how things change. And so a lot of my work has been in the last kind of 20 years about looking at change, like how we track change and use it in prediction. And so the work that Switzerland is doing, and they can do it. So they can do it. But they can also work on trees, and that's a great thing. Everybody wants something. So in the UK, we have the most beautiful time series maps. From 1860s, every 20 years. They were scanned in the 1990s by OS and a commercial company, which meant that there were joint copyrights. We can't get those scans to extract the outline, the historical footprints from or tree data or anything, because they're under that copyright. But Chris Fleet in the National Library of Scotland, he doesn't have all of them, but he is the most amazing map curator, and he wants to create open data. So he's releasing all the maps that they have, including quite a lot of kind of.
I think for people here who are new to the UK, OS is Ordnance Survey.
Oh, I'm so sorry.
This is a company, I think it's private now, isn't it? Or semi-private?
It is moved. It's basically I think it might be owned by a company owned by the government.
Okay. At any rate, they got rights to all the maps. They created the first maps back about 300 years ago, probably. And,
for military reasons,
1720, something like that, and for military purposes. And so they had a precise map of the UK, and they did several surveys. So now they own essentially rights to everything, including maps in the UK, and they have very tight control, very tight system is if anything with maps and OSs or this is involved, you can't get access to it.
Yeah, you can't, but they did give us the outlines for London.
Right.
And at first, they said no,
Yeah,
like a lot of
yes,
times.
exactly. So it's a strange situation where, as we heard from Polly, the maps exist. They're very beautiful maps and very good maps, very accurate, updated every year, and they're not accessible unless you pay them a lot of money because they want to.
But I think that this time series data is going to be the big one. It's the big one. Like whoever's got hold of that time series data, they're going to be able to do a lot with it. And so what we're trying to do is say, okay, like Andreas was, he was working on aerial imagery.
Yes,
And
trees in Cambridge, yeah.
But then he was going, oh, well, then I can look at the map. I can look at maps as well, because he was really interested in the idea of extracting from historical data on trees as well. So you just need the will, and then you just build a challenge to those. And then what happens is that you have such a great system in it, because everybody breaks, all these wonderful people are involved, that those people blocking it realize that they can enrich their data better. They can make more money out of their data by giving it to you, seeing it enriched, and then
Just like
repackaging it.
Microsoft and Linux. I mean, the same exact thing happened in operating systems. Bill Gates, Microsoft said, we own the operating system, we don't want to touch it. And then there was the renegade group, Unix, and then Linux, which came out. Unix started in '69, Linux came out in '92 or '93, and all these people doing individual things. But what they did was to have this partnership, this federation, as you call it, which allows people to contribute code, and it was under what's called the general GPL. So if you want to use something, you have to put it back in again. And that's led to this entire ecosystem. Now what Microsoft is doing is that they realize that actually they support Linux, because they make more money by supporting Linux in the data centers than supporting Windows. And so this has actually happened over and over again in different fields. And there's OpenStreetMap, as you probably know. Some of their Linux-like collective Wikipedia, Encyclopedia Britannica wanted to hold everything to itself, asked them to pay huge amounts of money, and Wikipedia said, we're just going to do our own.
Well, so we've just had this discussion with Overture, with their technical director, about, because Overture is Microsoft, Meta, Amazon, and TomTom merged together, and they are under Linux. So they argue that everything is kind of like, very open and very whatever. And we had a conversation with the other day because of this OECD meeting, which was brilliant. And I said, the trouble is that everybody's calling it Overture data. Right? They call what you've got there Overture data because you call it Overture data, but actually you just got most of it from OpenStreetMap in this instance, or you've got most of it from there. Why are you calling it open data? Could you change the name? Like, can you just change the name? If you change the name to the open data, the Overture portal, everybody be happy. Because they were saying, well, we really want to credit OpenStreetMap. And I was like, well, when I speak to my OpenStreetMap colleagues, what they're saying is that they don't really want the ingestion of computationally generated data into OpenStreetMap, because it's not what it's about. It's an organic, that bottom-up kind of thing, which is so important to keep. But Overture are ingesting everything the other way. So in the end, what you do is you undermine the value of potentially of OpenStreetMap, because you've got much more. Everybody's taking it for that. They're calling it Overture data. So we were with Oak Ridge National Laboratory, Overture, the OECD, and another thing, and they were very open. The technical director was very open to discussion. And I was saying, what we don't have is, could you just do some big visualizations of where your data are coming from, so we know where the government data is coming from. So
it's really important to realise that some of the most influential things in history, they had an integrity check, which meant you weren't allowed to alter them, but they made them freely available, things like the Bible. So you create a religion for 1 billion people by making it completely free. The only thing they did is you're not allowed to change it.
I think you would burn in hell, so it's pretty good.
We translated for a while, but then they gave up on that restriction. So
Well, it will
said,
be, I think, John, it'll be really interesting to see how far, kind of where we can get in this discussion, because I'm very skeptical, but I just think if you want everybody to collaborate, you have to created trust, a really
No, listen, yeah,
trusted.
yeah, no, absolutely. I think these issues that Jessica brought up of trust and actually identity is super important. Who is the person who wrote that nasty thing about you on your street map? Because you want, right now it's all, so without identity, without kind of a reference grid that everybody agree on, a reference metadata that people can agree on, at least common fields, it's not all fields, but some core common fields. And then attribution, if there's any payments also coming, so these kinds of issues show up in all sorts of other data sets as well, including the species data, the IUCN controls right now the red list and who's responsible. Even the names of species is controlled, right? And there's 6 different kinds of naming for the same species. We don't agree with each other. It
So
turns out.
that's the bit that we're really interested in working on, is this thing of that you have your standardized things, but there's this whole opportunity to create your own
Yeah, versions of it, yeah.
classes.
I mean, John and I come from the internet community. The whole purpose of the internet was exactly to create this open standards. In fact, the whole purpose of the internet is to define what we call the interfaces, so that you can innovate separately, but still conform to the same interface.
Well, yeah, and the World Wide Web Consortium followed that
Yeah,
as well.
way
So
back
they
then.
kept with them.
Yeah, so there's quite a few of these consortia in the computer science domain which have built really large systems. In Linux and the internet are 2 examples of the consortia that have worked bottom up and yeah.
I mean,
So
modular privacy, it's easy if you don't have a privacy challenge. So Frank Alley was chief scientist for transport in the UK, and he persuaded transport to publish all the information about where all their rolling stock, their buses and trains were publicly. So then a number of apps would develop really quickly by many people based on that. So that worked, but that was mainly because there wasn't any, obvious legal challenge over here. And there was an ownership thing, but most of it was public transport. So it was a proprietary competitive thing. But that which is the other side of things. But I think you're right that a lot of this data create more commercial opportunities by being freely available than by closing them. So yeah.
Well, I mean, my feeling is it's a competition between Google and the Overture group on who's going to monetize the social data space. But when you talk to them, it's not at all like.
They also make fake claims about, because they're big, they can assure you about provenance, which goes back to your point about where did it come from.
Yeah.
But that's not necessary either. There are many ways you can assure about provenance of information and its integrity. I don't think that's necessarily connected with some big commercial organization being in charge of it. I think we have some.
yeah, I think we should stop now. Thanks very much.
Thanks.